Hello everybody and welcome back to programming, where I figured out exactly why we were having that error. I had a couple of faulty assumptions. Now, the overall connection is absolutely fine, but let me just stop this. I was just debugging this a little bit. So there's actually absolutely nothing wrong with the server code. This is completely fine, except that this is not how you spell received. There we go. Problem solved. So the actual problem is this. I assumed that this was a header-only message. This is not a header-only message. This sends a message type and string message. So the problem here is that this datagram does not actually contain a delimiter. So what we need to do is we need to have this be string.format 0, 1, and we're going to pass in the int-parsed message type, followed by the message. Just like that. So that's our new datagram for the actual client. And this is, of course, in the client's UDP here. So that's all we needed to do there, because that was literally the only issue. It's completely fine. So now, if we run this, we should have no problems with the connection. So we'll just fire up the server, and we will fire up the client, and they'll just automatically connect and receive connection. Technically, we received the connection twice, apparently. Okay, I'm not sure why exactly we did that, but you know what? I think I know why we did. If we go into here, into the net manager, when we receive the key message, we don't actually do anything. Okay. Never mind, then I don't know why we received that twice. But for right now, that's not actually an issue. So we received a connection there. For some reason, it is sending that packet twice. But what I really want to do for this episode is I want to get our encryption handshake done. So that is our goal here. And we're just going to kind of go however long that ends up taking. So let's see here. We received this for sure. So let's just check and see if we can figure out why that would have sent twice. In the net manager, we are doing a init connection in start, client.connect to, init connection connected equals true, and then we send the message types.con. Okay, so we fixed one error, and we may have slightly found another. The question is, did this create... This should not have created another session. This should be the same session. So realistically, when it receives the con message, then it responds with a key message already. So that's fine. So when the client receives a key message, we need to handle that. So the client is already receiving a key message just as soon as we get back, except that we don't actually do anything with it. So we're going to need to hop over to the client here, and I will just pull that up on my other monitor so that I know what's properly going on here. So there's a few things that we're going to need to do in this parse message. There's actually quite a few things that we're going to need to do here. So first thing that we're going to do is we're going to put in a string time equals message.substring, because we're going to need to grab the timestamp off of this. Now, I don't think we're currently sending the timestamp, and that's something that we're going to have to consider. Are we sending the timestamp? Because we do definitely want to append a timestamp to everything coming from both the client and server. So let's check in the UDP here. Let's see. It doesn't look like we're automatically sending a timestamp. If we send this... Okay. I don't think we're sending the timestamp right now. If we go in here, int message type, yeah, we're not currently sending a timestamp. Okay, so we definitely need to do that. I think this version that I'm on here didn't actually have the timestamp in it. That's easy enough to do. All we're going to do is simply put in the timestamp at the end. So we're just going to, here, when it is sending a header-only message, then we're just going to append in the timestamp here, and this would be datetime.now.toString. Simple enough. Okay, so the server will automatically append a timestamp to the end of that send type. We need to do the same thing here. So we're going to do 2, and we're going to append a timestamp here, datetime.now.toString. Simple enough. And that's all we're going to do. We may end up formatting this a special way later on, but for right now, that's all we're going to do there. So the server is always going to send a timestamp, and the client really probably should too. So let's do the same thing here, where it's going to be 0, 1, 2, like that, and then message datetime.now.toString, same exact thing. And then we are going to do same thing down here, where how are we going to do that with a byte message? That's going to be interesting. We want to append this at the end. The datagram is a byte array. That is certainly exciting. Well, this is already a byte array. Can we append a byte array just by adding it for concatenation? I have no idea. If we were to do a byte timestamp equals new byte, this would need to be of the length of a particular length. So we'd need a string ts to know our length equals system. Actually, we don't even need to use system because we can just do datetime.now.toString like that. And then this would be a new byte array of ts.length. And then timestamp would be equal to encoding.utf8.getBytes of ts. Like that. And realistically, we probably don't even need to declare this like this. Byte timestamp equals this. We can just do that. And now, can we concatenate these? No. I didn't think we could. So, I need to try to remember how block copy works. Array source, source offset, array destination, int destination offset, int count. Okay. Yeah, that's going to be awkward, to be sure. However, what we can do is we can have the timestamp here. We don't need to declare this. We can just do datetime.now.toString, like so. Get rid of this. We do not need that anymore. And then we can do that. And then the datagram would be equivalent to header.length plus message.length plus timestamp.length. There we go. And then this copies in the header at position 0 into the datagram at position 0 for header.length's count. And then this copies message at position 0 into the array destination, which is the datagram, at header.length for message.length. So what we should need to do, if I'm understanding this correctly, is system.buffer.blockCopy, and we want to copy in timestamp at position 0 for our source offset into datagram at header.length plus message.length for the length of timestamp.length. This may need to be header.length plus message.length plus 1. And this is not going to be comma separated. So we actually need to put in a comma here. And technically concatenating these strings like this is not quote-unquote the right way to do it, but we'll just do that for now. And I don't know if this is going to be exactly correct, but it should be pretty correct in theory. So that should get us a timestamp from our client as well as from the server. And every message should now have a timestamp. So that is ideal. So we can now get our timestamp over here. And let me pull open the correct file so that I know where we're going with this. Perfect. This should be message.substring message.lastIndex of, and then we're checking for the last comma because this is comma separated values. But we also want to add one because we don't actually care about the comma. Excellent. Date time updated time equals date time dot parse exact. And here I'm using a very particular format, actually. So we should probably just copy this somewhat black magic string and use that in our toString methods for datetime.now. So this would be like this. So a 4-digit year separated by a dash, 2-digit month separated by a dash, 2-digit day, space, 2-digit hour, colon, 2-digit, apparently this is hard, minute, colon, 2-digit second, and then we're going down real low for how low we actually go in terms of our exact timing. So there we go. We'll just pass that in here as well for our server. Or actually, that's for our client. Perfect. And then we are going to do the same thing for this here in our server. So in our send, instead of just doing the default toString, we're going to have this very specific toString format so that we can parse that more easily. Excellent. So we want to parse exact time, and then we want to make sure that we're using this same format, and then culture info dot invariant culture. We don't care about the C# culture that you're using, whether you're in NUS or whatever it might be. We don't care. It's going to be the same thing every time. Okay, so we're going to need to know if we have our time initialized. So that should be a, let's see here, a public bool according to this, but I'm going to make it a private bool for right now unless we run into issues with that. So private bool time initialized equals false. Okay, so down here, if our time has not been initialized, we'll need to initialize it. So if not time initialized, then we are going to simply say time initialized equals true. Server time equals our new updated time because, nope, updated time. There we go. Now we don't currently have server time, and this one I think we probably will make be public. Public date time server time. Because we're going to need to know from a lot of different places what the current time on the server from the last time we knew was. Excellent. The other thing we want to do is we want to do a public float latency. That's a float, right? Surely I didn't use an integer for that. Yeah, that's a float. Fantastic. So, for that, we're just going to be measuring the time between the server time and our current time to determine what that latency is. Simple enough. Maybe not the most accurate, but we're going to initialize that at 0. And then we're going to come down over here, and we are going to say latency is still equal to 0f. Who knows, maybe we need to reset it or something. Otherwise, if the time is initialized, then we're going to need to say latency equals casting this to a float of the server time minus updated time dot total milliseconds. Excellent. And then our server time is equal to updated time. Like that. Okay, so that's just a little bit of time initialization and, well, timekeeping, so that'll be fine. In header length equals message.indexOf, which just returns the first index of a comma. So that gives us our header length. This is exactly like we did in the server. String header, and we're going to go with content because that's what I used previously. Although I think in the server I called it message, and oh, hello Steam library. I think I called it message over here. Let's see here. That should be under message processing. Yes. Except we actually did it here. Yeah, I called it message. So we're going to call it message here as well. Except we can't because this was what we called it here. Okay, we'll just leave it like this. It's going to be vaguely confusing, but the whole thing is vaguely confusing. So if our header length is not equal to -1, so if there is a comma in the string, then we are going to say header equals message.substring, and we're just going to grab the substring of the message up to that first comma. So up to the header length, and then content equals message.substring, and then this is going to be the rest of the string, header length plus 1. There we go. Otherwise, we apparently don't have a header, so the header, or rather, we apparently don't have a message. So the header equals the whole message, and content is just an empty string. Excellent. So now we're going to actually parse actually process the message now that we've parsed it out of the string. And we are just going to say switch. We're going to cast this into message types int.parse the header. That's exactly like we did on the server there. And then this is going to be case message types .con. That is not how I spell anything. This is a con message. The client really shouldn't ever get one of these. And all we're going to do if we receive a con message is debug.log warning. And that warning is going to be client received con message. This shouldn't happen. The server should never be requesting to connect to the client. Okay. Now the one that we're actually interested in for this particular bit here, we're going to say case message types dot key. We're already sending this, so we're already receiving one of these when we connect. This is a key message, of course. That's not how you spell. We just received a public key from the server. Let's record that and send back our own. Okay. So we're just going to break there for right now, but there's a few things that we're going to do here. So first off, we're going to say string XML message equals message.substring, and this is from position 2 to message.length -2. And that gives us our XML message while stripping out a little bit of the things that we don't actually need there. So next up, we're going to need an encryption manager for our client, which we don't currently have. So let's create a new C# script, encryption manager. Excellent. Now the encryption manager is going to be basically identical to the previous one, but we're going to run into a couple of issues here. More particularly, and actually I'm just going to, for now, hop into the encryption manager from the server, and we're just going to hard copy and paste it right now. That's going to be exactly the same, except it won't be. We're going to need a few more things on the client side than the server does, because the server does the client side encryption via the session, not via the encryption manager. Although that's kind of run via the encryption manager, it's awkward. But on the client side, we're going to need a reference to our own as well as the servers. We only ever need the 2 RSAs. So public static RSA crypto service provider client RSA equals new RSA crypto service provider. We're going to use a 2048 key size. Public static string client RSA key. We're going to need to store that as well. And we're going to do that right away. And there's a reason for this. I was doing it differently previously, and this causes issues and doesn't, strictly speaking, fix the issue I'm about to cover. But for right now, let's just do this. And we're only going to do the public key here. We don't care about the private key. And then we're going to make this be a private static string server RSA key. And we are going to just leave it like that. But then we're going to put in a public static string server RSA key with a capital S, because we're making a property. Excellent. So if we get this, all we do is we return the server RSA key. That's all we get. But if we're putting in a new RSA key, then we actually want to do something slightly differently. So we want to say server RSA key equals value, like that. But we also want to say, I need an R in here, but we also want to say that the server RSA should update to use this new XML string. So we're going to say server RSA key. Now, there is a fundamental problem in Unity that has existed, as far as I can tell from Googling, for at least 4 years. I don't know what causes it. I don't know how to fix it. We're just going to have to live with it for now. Unless we switch to a different crypto library, which is something I've thought about doing, and we may end up doing later, but for right now we're going to leave it like this. And I'll show you exactly what I'm talking about. So, the encryption manager here, this is currently going to happen outside of the main Unity thread. So we're not going to notice any difference with it like this. But if we take this, and I'm going to be reverting this, so if you're following along, don't do this. What we're going to do is we're just going to remove that, and in the net manager, in the start, we're going to say, before the init connection, we're going to say encryption manager dot client RSA key equals client RSA.toXML string false. And this will, of course, need to be encryption manager.client XML string. And I'm just going to put this back in here as it was, and we're just going to comment that out quickly, like that. And I'm going to demonstrate something for you. So, actually, before we do this, I want to change one thing. I want to comment this out again. Now, we're not going to fire up the server. In fact, I'm going to comment out this whole line. Like so. Now, we're not going to fire up the server here, and we're just going to launch this guy. And let's take a look at this. So it instantly client thread ends. That's fine. You see how quickly that starts up? That's no concern. That's like a second in startup time. Now, let's put this back. Take a look at this. Oh, that's a compiler error, of course. Because we need a semicolon here. Yeah, that's fine. So, take a look at this. Yeah. So this is a little bit slower. Yeah, quite a lot slower. So that takes a while, and it's not the same amount of time every time. Like, it's a variable amount of time how long it takes Unity to do this. This happens, it's a slow function, don't get me wrong. It's not this slow. Like, that was a relatively quick one. I have sometimes had it sit there for over 30 seconds before. Just from that one call, this one right here. Now, the reason that we're not doing it like this, and we're instead doing it like this does not fix the issue. But declaring it statically like this causes it to happen not on the Unity thread, so Unity fires up much more quickly, as it should. It fires up at its normal speed. But the static encryption manager is not actually ready to go for a little while because it has the same slowness. Now, this does not happen in the console application. It's a Unity problem. And it's one that I don't have any idea on how to fix, except for potentially not use system.security.cryptography. That's something that we can come back to, though. For right now, let's just take a look at what happens when we actually put in our key here. So, we're going to have to do a couple of things to prepare for this. So, when we receive the key, we're going to say encryption manager dot server RSA key equals XML message. Now, remember, this, when we assign it, does this from XML string call, and that has the same slowness in Unity as the to XML string call. So this is going to be a very, very slow thing to do. And we'll just have to keep that in mind. It's not as bad, actually. It's kind of bad, but not terrible. So we've got the server RSA key in here. And then all we need to do, now that I think about it, let's see, we're taking the time out of here, yeah. Header length. This does not take the timestamp into account, does it? I don't believe it does. Because this just goes header length +1. So maybe what we need to do is we need to say that this goes for the length of the rest of the string? I mean, it's already doing that. But maybe we need to remove the timestamp here. We'll address that potentially later. For right now, I think we are going to just simply debug.log the message like that, just so that we can see what it's actually working with, and we'll just proceed for now. So we need to respond with our own public key so that we can talk privately at some point. And we're going to say client.send message types.key, and we're going to send encryption manager.client RSA key, which we've pre-calculated at this point. Okay, so then we're just going to debug.log handshake complete. We're not going to send an acknowledgement just yet. So then the server will have received that, and let's hop into here. Have we already implemented that? Yep, so the server receives it and stores it, and we will then have it also output. Once it receives that, it will then just output client actually encryption handshake complete. Okay, so once both of them are complete with the handshake and have the information that they need, they will both output encryption handshake complete, and we should be good to go. Now, that's assuming that we don't have timestamp issues here. And I also want to do a system.diagnostics.debug.writeLine, and I want this to be just outputting the message, because I want to make sure that we don't have timestamp issues. I suspect we will. So let's go ahead and fire up our server here, like so. Okay, server is online, and let's run this. Now you'll see there's nothing here because we're waiting on the encryption manager, in theory. What have we received here? Exception thrown, system.security.cryptography.cryptographic exception. Right, because we've got our RSA key value and modulus here, And then at the end, it appends the timestamp, as expected. So we need to truncate the message here. So we need to actually be fishing out the timestamp in the same way that we are here. So we need to grab this, and we are going to hop into the server. We're going to paste that here. But instead of doing date time updated time equals this, we're going to say that the last message equals the timestamp of when that was received. And culture info does not exist. We'll have to use system.globalization. That is fine. Okay, so that gives us our timestamp there. And then we should go ahead and subtract the timestamp off of this. So the string should be truncated by the length of time plus 1. So message.substring, we're going to say that message equals message.substring. And we're going to go from position 0 to the position would be message.length minus time.length plus 1, because we want to include this comma. Okay. So now the question is, why did we... Oh, we did receive a handshake complete here eventually. Okay, and yep, you can see the same timestamp is here of what we received from the server. So we want to make sure to remove that timestamp on the client as well. And let's see, we're doing that there. So then we just want to grab this same thing. There we go. So we're just going to remove the timestamp off of the message after we've already recorded it. So that'll be fine. So in theory, we should now be able to launch this, and we should eventually receive a handshake complete with no exceptions on both client and server. So this will take a little bit of time. Received a connection. We're waiting on the encryption manager. Okay, no exception here. So we can see that we received our key. That's perfect. Encryption handshake complete. And handshake complete. Fantastic. And I'm actually going to change that to read the same thing. So we're going to go over here and we're going to say, instead of handshake complete, encryption handshake complete. Fantastic. So we now have the ability to communicate back and forth via encryption. Now, we're not going to encrypt a lot of our communications because they simply don't matter. But some things, like passwords or potentially credit card details, please make sure that you're actually that you actually know what you're doing with these cryptography libraries if you are going to store credit card details. But yeah, I think that we're pretty much in a good position here. Our encryption handshake is done, and we are pretty much ready to move on to potential logins and database work. So that'll be great. For now, though, I'm going to go ahead and put a cut in here. We've pretty much achieved our goal. This was a bit of a shorter one than the last episode, but we're kind of just going to a particular goal, implementing up until there, and calling it good. So that's what we're going to do for right now. You can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I will see you all next time.